Okay, we're at the study session Wednesday, and we're talking about fraction multiplication. The question that we are actually going to look at is from the textbook, section 1.2, homework number 75. So I'm going to grab that, and I'm going to put it on our whiteboard, but I'm not going to put it right at the first slide. We're going to work our way up to it a little bit, because this one has 3 fractions and we're going to want to use canceling. So let's pretend that we need to learn about 2 fractions first and why canceling happens. So in the website, I'm going to go to Add Science, this girl doing chemistry here. Whoops, switch which page I'm looking at. Okay, so now I'm going to look at the girl doing chemistry, Mad Science, and that's about squishing things together without equal signs yet. So that's what we're doing. And I will go to the very first topic, fraction multiplying. And so here's a quick version of if you are my Math 20 student learning about fraction multiplying, what are we doing? Everyone ready for this?
Yeah.
Okay, so I'm going to grab this little cake picture and say, what's happening if we wanted to do 1/3 times 1/2? And you might have heard that multiplying I can usually replace with the word of. So it's 1/3 of 1/2 or 1/2 of 1/3. So I have my 1/3 already. That's this one here. So I want to take half of that. So how would I draw that on the picture?
You want half of it, so would you just split it in half?
Yeah, so I cut the whole cake in half. And I say that the half I care about is going to be like the top half, right? So the blue half matches up with this blue half here. And the black third matches up with this black third here. Everyone with me so far?
Yeah.
So we know how to do this. We've been taught this. We go across the top. 1 times 1 equals 1. 3 times 2 equals 6. Where is the 1/6 on my picture now?
Would it be the last box?
It's this overlap box, right?
Oh.
This one is the 1/6. It is where the third and the half overlapped. So what happened kind of philosophically there? How did we get from 3 times 2 is 6? What's happening in the picture that makes 3 times 2 is 6?
All the boxes are getting smaller.
Yeah, these thirds that we started with. Oh, wrong one. These thirds I started with, we chopped them in half and they all turned into 6 when we made that extra line, right? So the denominator of a fraction is how big a piece are we dealing with? It takes 6 of them to make a whole now. 1, 2, 3, 4, 5, 6. The numerator of a fraction is how many pieces are special. How many do we care about? We used to care about just 1 of the thirds. And then we started caring about just 1 of the halves. And where those overlapped was just 1 of the 6ths.
Got it.
Okay, so that's step 1. That's why does fraction multiplying work? How come we can go across the top and across the bottom separately and just multiply? So the next step is to talk about reducing. So let's multiply 3/5 and 1/12. So 3/5, 1/12. 3 times 1 is 3, going across the top. 5 times 12 is 60. And in one sense, this is correct, right? 3/60 is the right answer. But there's this annoying rule that fraction answers don't count as done until they're reduced all the way. So most math rules and physics rules, you get somebody's name, Fermat's theorem or Newton's laws of motion. But whoever made up this rule, we don't know their name. We would all hate them instead of admire them. But this is one of these rules we have to follow, that fractions have to be reduced to be counted as all the way done. So in this case, I can divide top and bottom by 3. And I get 1/20th as my final answer. And I admit I didn't explain how to reduce fractions. That's a different lecture topic that would be earlier in Math 20. But for now, I'm assuming that's okay. So is everyone okay with what I've written, or do you need a backup about this step later on?
I guess I'm kind of wondering, is the 3 just because it's on top, or is that just because it goes into both numbers?
It's something that fits into both. And
Okay,
once I
so it doesn't matter what numbers it'll be, it's just something that fits in both of those.
Yep. And if you pick the biggest number that is a factor of both, you'll be done in one step. If you don't, then you'll have to take several steps. Going. Okay. So I'll show you a multi-step thing next. Let's do that, because that's a great segue. Now let's multiply 10/15 and 6/8. So 10/15 and 6/8. 10 times 6 is 60. 15/8. Well, 10/8 is 80. 5/8 is 40. And if I add up the 10/8 and the 5/8, then 80 and 40 would be 120. So I could say all is one step. I'm really awake. I had a good night's sleep. I think the biggest thing that goes into both the top and the bottom is 60. And right away in one step, I would get to 1/2.
That makes sense.
But maybe I'm not that awake. Maybe it's early in the morning. I haven't had my caffeine yet. So maybe I only noticed that 10 works because of that big fat 0 sticking on the end that's easy to see. Then 60 divided by 10 is 6. 120 divided by 10 is 12. I'm making progress. There's nothing wrong with this. It's not like I'm a better person because I could do it in one step versus 2. But I'm not done yet. There's still something else that goes into both of these. And just because I'm running out of room on my slide, I'm going to say it's 6, so I'm done. But you could do 3 first and then 2, or 2 first and then 3, and take even more steps to finally be done. But eventually, you're going to get to the same answer, no matter how much reducing steps you do. And if you do a bunch of these, then you notice, this is too much work. What I want to do instead is take my 10/15 times my 6/8, and I don't want big numbers on the page. The fact that I wrote a 60 and a 120 is just making life hard for me. If I could get to 1/2 without writing something as big as 120 on the page, that would be cool. So I know I need to divide a top and bottom by the same thing. That's how we reduce fractions. And so in this case, what's something that I have common factors of some number, top and bottom? I might notice, oh, I can say, let's do a divided by 2 here and a divided by 2 here. And that changes this into a 5, and that changes this into a 4. And let's do a divided by 3 here and a divided by 3 here. And that changes that into a 5 and that into a 2 and things like that.
And then you just go across?
I could cancel more because my 5s, I could cancel a divided top and bottom by 5. I could do more canceling here because the 2 and the 4 have a 2 in common. There's no virtue to doing all of your stuff canceling versus reducing. But the point of this one is just that canceling is reducing early. Now I didn't have anything as big as 120 on my page.
Makes sense.
Right? So I normally wouldn't write it like this, the way most people would do this problem on their paper. And a big part of math is putting things on your paper the right way, as I would just go like that. And if I have fancy colors, I might do that. Why would I use my fancy colors? Because then when I'm studying for the test at the end of the term, I can say, what did I do here? Oh, those two go together. Those two go together, right? I could be a super canceller and say the 5s divided by 5 is 1, and the 2s divided by 4s, divide by 2, divide by 2. And now when I multiply across, 1 times 1 is 1. That's all that was left. 1 times 2 is 2. So different ways to write the same problem. But canceling is just reducing early. I have to divide by 60. Whether I do it all in one step is 60, whether I break it into a 10 and a 6, whether I break it into a 5, a 2, a 3, and another 2. Eventually I will divide by 60 to get my answer. But sometimes it's easier than others. And if you're confused right now, that's my fault because I just did the same problem in 3 different ways. So of course that's confusing. But the moral of the story is almost no one writes this. They will do something more like this, where let's do a little bit of canceling. And then when it looks easy, I multiply. And then I do any reducing I still need to do, and then I get my answer. Okay, now let's go back to this official homework problem, which looks fuzzy. So I'm just going to resize it and rewrite it because copy and paste failed me. Okay, so we have 3/7 14/18 times 6/2. And I could just brute force this. I could multiply 3 times 14 times 6 and get some giant number here, and that would be painful. So let's do some canceling first.
And Journey, this is what you were telling us, right? Okay.
Yeah, yeah.
So pick any 2 numbers that have a common factor and we'll do some canceling.
I chose to do the 14 and the 18, what goes into those.
Okay, so what's something that goes into 14 and 18?
So I did 2 times 7.
Mm-hmm.
And then for the 18, I did 3 times 6.
But then you don't have something in common to cancel out.
Oh, well, I ended
So
up
if you're thinking this one is 2 times 7, let's make this 2 times something so we can cancel out those 2's.
Oh, well, I chose to do the 3 times 6. I guess it's more complicated, but I chose to do it that way so I could cancel out the 3 and the 6 and the other numbers.
Okay, great. Let's do that then. So I will write it that we have a 3 and an 18. We'll do a divided by 3.
Mm-hmm.
That puts a 1 here and a 6 here. And then Journey said she wants to do divide by 6 top and bottom, which puts a 1 here and a 1 there. Is that a better way to write what you were thinking?
Yeah, and I can show you kind of on my screen.
Okay.
If that
Let
helps.
me stop sharing mine. And okay, show your screen.
So I got it wrong, but it was just I put 0 instead of 1. So I chose to do 3 times 6 for 18 and 2 times 7 for 14. And that way I could cancel out the 7 on the bottom there. and the 7 here, and also the 6 there and the 6 there, and the 3 there and the 3 there, and then the 2 there and the 2 there.
Beautiful. Okay, I'm going to share my screen again. And I
Okay.
actually use my grab things from the screen superpower. So here is a copy of what you were doing. And some people like this. If I write out all of these factors, then it makes it easy to know, this 6 and this 6 and so on. But I don't tend to do that when I'm lecturing because most people write it with slash marks and just sort of this way.
Yeah.
But if you like being very thorough the way Journey wrote it, that's a great way to do it. Most people are too lazy. Anyway, we've gotten our 3 and 18 canceled. We've got our 18 and 6 canceled. We could multiply across the top and get 14 over 14. That's not a giant bunch of numbers. Or we could do more canceling. Anyone care?
I think that's where I got messed up and put 0, because I should have just, if you multiply, you get 14 over 14. Mm-hmm. But like, since I thought everything canceled out, I thought it was 0, but it was actually 1.
Right. So a habit I have, which if you haven't been taught before, it's not your fault. When you're done with the canceling, leave 1s around, because 5 divided by 5 is 1. 2 divided by 2 is 1. And that way, when you do multiply across, you remember it's a 1 and don't put 0 by mistake. Because otherwise, yes, it's a very common mistake. If you think things are gone because of canceling, then you put 0s instead of that something divided by itself is 1.
So I have to go pretty soon. I was going to ask a question about the writing assignment. I was